you ever wondered, if we could rewind time far enough, would we reach a moment when the universe didn't exist? We often assume everything has a yesterday, but one of the most profound ideas in science is that the universe did not exist forever in the past. It had a beginning, a moment when time, space, and even matter itself had not yet emerged. In 1927, Georges Lemaitre, a Belgian priest and physicist, first proposed the concept of a primeval atom, the early version of what we now call the Big Bang. Before that, people believed the universe was eternal and unchanging. But things changed when Albert Einstein introduced general relativity, and Edwin Hubble discovered that galaxies were moving away from us. That led to a revolutionary conclusion. If the universe is expanding, then in the past, it must have been incredibly small, possibly a single point. At that point, the day without a yesterday time itself had not yet begun. Asking what came before the Big Bang is meaningless, because before requires time to exist, and time was born with the universe. Just like each of us has a moment when we came into being, the universe too had a beginning. A moment of unimaginable transformation. A moment without a yesterday. There, since we first looked up at the stars, one question has echoed through the minds of scientists. How did the universe begin? This search for answers is more than just an intellectual pursuit. It's one of the most ambitious challenges science has ever faced. To uncover the universe's origins, physicists have drawn upon everything we know, from general relativity and quantum mechanics to the laws of thermodynamics, especially entropy. Exploring the cosmos with every tool we have, thanks to powerful telescopes like James Webb and Hubble, we can now observe the universe across the entire electromagnetic spectrum: radio waves, infrared, visible light, X-rays, gamma rays, each revealing different cosmic secrets. Radio waves show us ancient galaxies, billions of light years away. Infrared lets us peer through cosmic dust to witness stars being born. X-rays and gamma rays expose black holes and violent cosmic events, a blend of cosmology and particle physics. Scientists don't just observe, they also build mathematical models and test theoretical frameworks like general relativity, which describes the curvature of space-time quantum mechanics, which governs the strange behavior of particles. The lambda CDM model, which combines dark energy, dark matter, and ordinary matter into one cosmic framework. But is the Big Bang really the beginning? The Big Bang theory is still the most widely accepted explanation for the universe's origin. But even it leaves us with some mind-bending questions. What existed before the Big Bang? What triggered it? Is there something beyond our universe? That's why science isn't just trying to explain how the Big Bang happened, but also exploring. If the Big Bang wasn't the true beginning, then what happened on the day without a yesterday? If you were present at the moment of the Big Bang, what would you see? The answer is probably nothing at all. A cosmic explosion, but not what you think. The Big Bang wasn't an explosion in space. It was the sudden expansion of space itself, an unimaginable release of energy that stretched the fabric of the universe. Around 10 to 36 seconds after the Big Bang, a mysterious event called cosmic inflation took place. In less than a billionth of a second, space expanded faster than the speed of light, growing in size by a factor of billions, faster than thought, beyond comprehension. The entire process happened so quickly that if you were somehow there, you wouldn't have been able to perceive a thing. Time itself was flowing too fast. Changes occurred on the Planck scale, the smallest unit of time science can currently define. About 5.39 was 10 to 44 seconds. To capture this moment on video, we'd need a camera capable of recording 5 quintillion frames per second, a number beyond our current technology. Inflation explains the unexplained. We can't observe cosmic inflation directly, but it explains some of the most puzzling features of the universe. Why the universe looks nearly identical in all directions. Why galaxies are distributed evenly across space. Why the shape of space is nearly flat, not curved. Without inflation, the Big Bang theory isn't enough. Inflation fills the gaps that the Big Bang alone can't explain. It gives us a framework to understand why the universe looks the way it does, and hints at something even more profound. Our universe might just be one small bubble in a vast cosmic ocean that continues to expand and evolve endlessly. In our everyday world, every effect has a cause. But in the universe, some effects may happen without any cause we can ever reach. Cause and effect, the foundation of logic. In human experience, causality is everything. Every outcome stems from a prior event. The past shapes the future. That's how we predict, understand, and make sense of the world. But the universe has grown too big for cause and effect to apply. Today, the observable universe spans about 93 billion light-years across, and it's still expanding at an ever-accelerating pace due to a mysterious force called dark energy. This expansion is so extreme that entire regions of space are being pulled apart permanently. Even light, the fastest signal in the cosmos, can't bridge the gap anymore. A thought experiment, the unreachable star. Imagine a new star forming 46 billion light-years from Earth. Even if it emits light right now, that light would take 46 billion years to reach us, if space were static. But space isn't static, it's expanding. So by the time that light gets close, the distance might already have stretched to hundreds of billions of light-years. The result? That light will never reach us, ever. From our perspective, that star might as well not exist. Causality breaks down. In this context, causality no longer applies. Events in vastly distant parts of the universe can never influence each other. No signal, no interaction, no shared information, no connection at all. It's a sobering realization. The universe is growing in ways that even our most fundamental rules can't keep up with. The universe stretches across billions of light-years, and yet it looks almost the same in every direction. That's not normal. A strangely balanced cosmos. Thanks to satellite missions like WMAP and Planck, we now have precise measurements of the cosmic microwave background, CMB, the afterglow of the Big Bang. And what we found is astonishing. The universe's temperature is nearly identical everywhere. The CMB is about 2.725 Kelvin, with variations of only 0.001 K between regions. In simpler terms, the universe is incredibly smooth and even-like. It was painted with one giant cosmic brushstroke. But how is this even possible? According to physics, for two regions of space to have the same temperature, they must have exchanged energy. They must have been in contact at some point. But here's the problem. Many of these regions are so far apart that light has never had time to travel between them, even since the Big Bang. So how did they know to sync up? The answer? Cosmic inflation. Inflation provides a powerful explanation. Before space expanded at breakneck speed, the universe was once tiny smaller than an atom. All regions were in close contact, exchanging heat and energy, reaching a uniform state. Then, inflation happened, stretching those once touching regions far apart. Imagine drawing dots on a balloon. Before inflating, the dots are close together. After inflation, they're far apart, but they still share the same initial conditions. That's why distant parts of the cosmos look so similar today. They were once neighbors in the same tiny universe. Not just a curiosity, it's a clue. This strange uniformity isn't just a fun fact. It's a major piece of evidence for inflation and a key to understanding how matter clumped together, why galaxies formed the way they did, and why the universe, as vast as it is, feels so connected. What if our universe is just one bubble, floating in a vast cosmic ocean filled with countless others? Inflation doesn't stop, it multiplies. In the theory of eternal inflation, the expansion of space isn't a one-time event. Instead, it happens over and over, in a larger quantum environment known as the inflationary field. Within this field, random quantum fluctuations cause different areas to pop into existence. Each of these pops becomes its own universe, like a bubble forming in boiling water. Each bubble is its own universe. Every new bubble has its own space and time, may have different physical laws, could even contain matter and forces completely unknown to us. And these universes never interact with each other, because the space between them expands too quickly for any signal to cross. This gives rise to a radical but increasingly accepted idea. The multiverse, a collection of countless universes, including our own. What's the science behind it? The idea of a multiverse isn't just science fiction. It emerges naturally from quantum field theory, where energy fluctuations are unpredictable, scalar fields, which drive inflation, advanced theories like string theory and M theory, which allow for multiple dimensions and parallel realities. Some physicists, like Alan Guth, Andre Linde, and Stephen Hawking, have proposed that the inflationary field may have no beginning and no edge. It could exist eternally, forever spawning new universes like ours. If this is true, everything changes. If our universe is just one of many, then it's not special. It's not central. And everything we know, our laws of physics, even the concept of time, might be just one version in an infinite set of possibilities. A humbling thought. We may live in a single bubble, adrift in a cosmic foam without end. What if our universe is just one bubble, floating in a vast cosmic ocean filled with countless others? Inflation doesn't stop, it multiplies. In the theory of eternal inflation, the expansion of space isn't a one-time event. Instead, it happens over and over in a larger quantum environment known as the inflationary field. Within this field, random quantum fluctuations cause different areas to pop into existence. Each of these pops becomes its own universe, like a bubble forming in boiling water. Each bubble is its own universe. Every new bubble has its own space and time, may have different physical laws, could even contain matter and forces completely unknown to us. And these universes never interact with each other, because the space between them expands too quickly for any signal to cross. This gives rise to a radical but increasingly accepted idea. The multiverse, a collection of countless universes, including our own. What's the science behind it? The idea of a multiverse isn't just science fiction. It emerges naturally from quantum field theory, where energy fluctuations are unpredictable, scalar fields, which drive inflation, advanced theories like string theory and M theory, which allow for multiple dimensions and parallel realities. Some physicists, like Alan Guth, Andre Linde, and Stephen Hawking, have proposed that the inflationary field may have no beginning and no edge. It could exist eternally, forever spawning new universes like ours. If this is true, everything changes. If our universe is just one of many, then it's not special, it's not central, and everything we know, our laws of physics, even the concept of time, might be just one version in an infinite set of possibilities. A humbling thought. We may live in a single bubble, adrift in a cosmic foam without end. Thanks so much for watching until the end. If you found this journey fascinating, I'd love to hear your thoughts. What do you think came before the universe? Do you believe in the multiverse? Does knowing how small we are change how you see life? Let me know in the comments. I read every one of them. And if you want to join me on future voyages across time, space, and everything in between, subscribe to the channel, hit the bell, and never miss a new episode. Until next time, stay curious and keep looking up. See you in the next video.